Hello, and welcome to this World Geography online training content video brought to you by the Georgia Department of Education. In this video, we will be addressing Georgia Standards of Excellence SSWG 4A, assessing populations through various means. Let's look at the standard and element we will address in this video. SSWG 4 asks teachers to teach students to assess the characteristics, spatial distribution, and migration of human populations on the Earth's surface. Let's unpack that a little bit. The standard is essentially asking, why do people live where they live, and what factors influence them to move away from or to a different place? Element A asks teachers to teach students to assess demographic patterns of population using graphs, maps, and other models. For example, demographic transition model, population density maps, and global migration patterns. Now let's unpack the element. This is essentially asking, how do geographers use a variety of ways to measure changes to populations around the world? In fact, these questions could be used as essential questions for and within a unit of instruction on this standard and element. It is important for students to understand that populations around the world are dynamic, not static. The makeup of populations, referred to as demographics, change regularly due to external and internal forces, including push and pull factors. It is imperative for students to recognize that geographers use more than one way to measure these changes in populations and attempt to identify trends. For this video, we will look at three specific ways geographers assess demographic patterns of populations in general, trying to understand how each is a different and useful tool. Then look at specific examples for some to further our understanding and applicability. We will look at demographic transition models, population density and distribution maps, and finally, population pyramids. We'll save global migration pattern maps for a later video dealing specifically with migration. Okay, let's start with demographic transition models. Out of the different tools of geography we're looking at in this video, this is likely the least familiar to teachers. PopulationEducation.Org is a good source to learn more in depth about this model and will provide many of the concepts and the visual. So, what are the basics? The demographic transition model looks at changes in overall population, birth and death rates due to changes in technology and economy to identify stages of demographics in a place over time. Let's look briefly at each stage. Stage 1 is characterized by high birth and death rates and a resulting steady but low population. This stage reflects low technology and little development, essentially pre-industrial revolution. Stage 2 introduces modern medicine. Death rates drop significantly while birth rates remain high, resulting in an exponentially growing overall population. Many underdeveloped countries around the world today are in Stage 2. In fact, according to the CIA World Factbook, the top 9 countries in the world in regards to total population growth are all on the continent of Africa. Stage 3 is characterized by declining birth rates due to improving economic conditions, the changing role of females, and access to contraception. Thus, overall population continues to rise in Stage 3, but not as rapidly as Stage 2. Most developing nations in the world today find themselves in Stage 3. Stage 4 is characterized by dropping birth and death rates. An increased emphasis on education, economic development, and medicine, along with other factors, stabilizes both birth and death rates, leveling out overall populations. Most developed countries are somewhere in Stage 4. A theoretical Stage 5 is characterized by a further decrease in birth rate, but steady death rate, resulting in a decrease in overall population. Factors that may lead to this are increased urbanization and high cost of raising a family in the city. Political stability and economic outlook may also play a factor in decreasing birth rates. The Baltic states of Estonia, Latvia, and Lithuania maintain 3 of the bottom 8 spots in the world in terms of population growth, according to the CIA World Factbook. Each has a negative population growth rate. One factor that is not considered in the demographic transition model is migration patterns. For this reason, a country which might otherwise be in the theoretical stage 5 still appears to be in stage 4. Next, let's look at population density and distribution maps. While similar, there is a difference. I often tell my students that population density is a simple mathematical way to look at population. Density is a measurement of how much of something exists over a certain amount of space. For example, the number of people divided by the amount of land. In other words, density is a measurement of thickness. I use the example of a milkshake compared to a glass of milk to help my students understand. A really thick milkshake, like the kind you can hold upside down and not lose any, is a good example of a dense population, whereas a glass of milk is a good example of a sparse population density. Population density maps can be vague, especially overall population density maps. Population distribution maps, on the other hand, give a more specific way to look at the same information by looking at specific units of measurement and not comparing it to the amount of total land. Neither measurement considers how much of the land is suitable for agriculture, however. People tend not to live on land that is not arable. Considering arable land results in 2 separate measurements of population density: arithmetic and physiologic. Arithmetic population density is simply the number of people divided by the total land area. Physiologic population density is the number of people divided by the total arable land. Each measurement helps geographers understand something different about the place in question. For example, the arithmetic population density of the United States is about 87 persons per square mile, whereas the physiologic population density is 482 persons per square mile. This tells us something about the total available arable land in the United States. Some countries have an even more striking difference between arithmetic and physiologic population densities. It all depends on the total land area of the country and the total amount of arable land. The third and final tool geographers use to assess patterns and demographics that we'll be able to look at today is the population pyramid. A population pyramid incorporates 2 new sets of data neither of the previous 2 tools considered: age and gender. A population pyramid breaks the total population into several age ranges and distinguishes between male and female. This helps geographers notice trends in population, like the impact of historical events and social policies. For example, here is a population pyramid for Russia, showing the impact of Soviet policies and World War II on the population. Here is a population pyramid for China, showing the impact of the one-child policy on the young female population there. Population pyramids can also help geographers predict further trends and inform social policies. For example, here is a population pyramid of the United States, which might influence policymakers to increase the retirement age and the age of eligibility for Social Security benefits due to the baby boomer bulge in the pyramid moving up. Each of these tools we have assessed today is unique and helps geographers and students alike learn about the demographic patterns of populations around the world. It is important that students understand why these tools are necessary to measure constantly changing populations across the planet. Here are some helpful links for further learning. Thanks for watching.